Hi everyone. Today we're going to be looking at solving quadratics by square roots. This is page 10 in your notes packet for chapter 4 that you have, and if you don't happen to have that with you for the asynchronous day, then take a look at our Google Classroom to pull up the notes from there. So far we've talked about solving quadratics by graphing, and you could look to see where they cross the x-axis. Then we talked about solving quadratics by factoring, where we would try to factor the trinomial into two binomials. And next we're going to look at how to solve quadratics by square roots. So this will go pretty quick because the last page just reminded us how to take a radical and simplify it. So once you've done with simplifying radicals, then this next section goes pretty quick. Now, the whole reason we can do this is this top section here. If a quadratic equation can be written in the form of x squared equals n, n meaning a number, the quadratic can be solved using the square root property. So what this means is if you were trying to isolate the x or get the x by itself, then you would have the square root of both sides. Now, as a reminder, I put plus or minus there because if I had something, for example, like x squared equals 25, then it would be true that x can be both -5 and +5 because either one of those squared will result in a positive 25. Okay, so let me erase some of those. Okay, so now looking at how to solve quadratics using this property, first you would need to rewrite it as x squared equals n. Then we're going to take the square root of both sides, but remember that we have a plus or minus that we have to consider. So we're going to do a few on this page. We will not work through every question, but I'll kind of go down this middle column here. And then you can take a look at how to solve some of these on your own and check with the notes to make sure that your solution is correct. Okay, so for example, let's start with number 14. If my goal is to isolate the x squared, I'm going to subtract 8 first. Okay, so that one's pretty straightforward, right? X squared is equal to 1. Now remember, if I'm taking the square root of both sides, then my result would be not just 1, but would be plus or minus 1. So I can also write that as x is equal to the set of -1, +1. Meaning that if I were to graph this function, set it all equal to 0 and graph the function, then I would be able to see that this crosses the x-axis in two places or two solutions at -1 and +1. Okay? Now, for something like number 17, if I'm solving to get the x squared by itself, then I would be left with 2x squared equals, my math here, 64, divide by 2, and I'm left with x squared equals 32. Now this is not going to be a perfect square. That's okay. We're going to simplify that square root so that I'm left with x is equal to plus or minus the square root of 32. 32 can break down into 16 times 2, which means I should have the square root of 16 times 2 plus or minus the square root of 16 is 4, and then 2 is left inside of the radical sign. So that means I should have two results as x is equal to -4 square roots of 2 and +4 square roots of 2. Okay, so that means this right here is my solution. Now, if you were to look at this one on a graph, 4 times the square root of 2 ends up being an irrational number. So whenever you're looking at the graph, it would not cross exactly at a lattice point. It would cross in between the units. So just as a heads up, this is the most precise answer that I can get. I cannot simplify it any more than that. And by typing it into a calculator and getting a decimal, that's less precise, not more precise. Okay, we'll do 2 more and then we're about done. Okay, so we'll look at 20 and then 23 looks a bit different, but the process is the same. Okay, so for number 20, subtract 5x squared is equal to 300, divide, so you get x squared is equal to 60. You can take the square root of both sides. So x is equal to plus or minus the square root of 60. However, if you were trying to simplify this or put it in its most simple form, 60 can be broken down many ways, but if we're going to try for a perfect square, then we're going to end up with 4 times 15. So then square root of 4 is a perfect square and 15 is left inside. So then we're going to end up with plus or minus 2 square root of 15. Now if I'm writing that in set notation, I would have x is equal to negative 2 square root of 15, positive 2 square root of 15. Okay, so those are my two solutions. This crosses the x-axis in two places. And then looking at 23. Now 23 does have an exponent of 2, but it's not just on the x. It's on the entire expression of x minus 1, quantity squared. So if we can get this entire expression isolated and then take the square root, we will still be able to solve using square roots. So first I'm going to divide by 3. So I'm left with x minus 1 parentheses or quantity squared is equal to 6. Now notice the entire expression x minus 1 is squared. So if I'm solving this, I can take the square root of that entire expression so that I'm left with x minus 1 is equal to the square root plus or minus the square root of 6. So that looks great. Now I don't have an x squared. However, the x is still not isolated. So what that would look like if I'm going to still isolate or solve for my x, then I'm going to add 1 to both sides. Now I cannot add 1 inside of the radical sign, so I'm left with x is equal to, we can write plus or minus the square root of 6 plus 1, or we can write 1 plus. So I can write it as 1 plus the square root of 6, 1 minus the square root of 6. And the reason I changed the sign on the negative 6 and not the 1, so I'm adding 1, but this is the thing that has the two different signs on it. So it's either plus square root of 6 or minus square root of 6. It would still be correct if I put a negative, negative square root of 6 first and then plus 1. However, this kind of keeps things neater and more organized. Usually the square root goes second. Okay, so those are some basics of how to get those isolated. Now notice number 23, we could still use square roots because it was in that format as long as you can get the entire expression isolated. All right, good luck.